All right, so locating critical points. So we let's start with A right here. So it says for each of the following functions, find all the critical points. And then it says use a graphing utility to determine whether the function has a local extremum at each of the critical points. Okay. So for part A, we have this function, right? And what I want to do to find a critical point is find the derivative, right? Because I'm trying to figure out where the derivative is equal to 0 or is undefined, right? And so the derivative here, if I here I just have to have a polynomial, so I'm just going to use the power rule a few times. So if I multiply by 3, 3 times a third is 1, and then I take away, so I get 1x, and then I take away 1 from the exponent, so I get 1x squared. Here, if we multiply by 2, we get negative 5 halves times 2 is just negative 5. And then we take away 1 from the 2, and so we get x to the first. And then the derivative of 4x is just 4. All right. And so what I want to do is, now that I have this derivative, I want to set it equal to 0. Okay, so I'm going to set it equal to 0, and I'm going to solve. And in order to solve this, I could do a few different things. I could complete the square, I could use the quadratic formula, or I can factor, right? And sometimes factoring is not an option. The other two always work. But in this case, factoring does work. There are numbers we can multiply to get 4 that we can add to get 5, right? And so I'm going to factor this out. And so we get x here, and then the numbers we can multiply to get 4 that we can add to get 5 are 4 and 1. Okay, so this tells us the sign of the bigger number, so that means the 4 is going to be negative, and this tells us the signs are the same when that's positive, and so that means the smaller number is also going to be negative. It's going to be the same, right? And so our when we set these equal to 0, we're going to get x equals 4 and x equals 1, right? Remember, we always change the sign there because we're trying to figure out what value for x makes this equal 0, right? So positive 1 minus 1 equals 0, and positive 4 minus 4 equals 0. All right, so those are our two critical points, right? There are no values where this is undefined. Polynomials are defined everywhere, right? The domain is from negative infinity to positive infinity. And so these are where the critical points happen, right? So critical points, and you can just put CP, critical points, and those are the two values where they happen. So now let's look at the graph and see if those are mins or maxes. Okay, so we can see at 1 we have a local max, right? It's not an absolute because this graph goes up forever. And then we can see at 4 we have a local min. Okay, so this is a local minimum, and this is a local max. Okay, it doesn't matter which order you put them, but does make sure you match up the right, the min or max with the right value. Okay. All right, so that's how you find critical points. So we'll do part B next.